welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I am Saloni Narang, CNCF Ambassador, Docker Captain. I will be your host today. Every week, we bring a new set of presenters to showcase how to work with cloud native technologies. They build things, they will break things, but they will answer all of your questions. In today's session, I'm stoked to introduce Amanda, who will be presenting on how to self host an AI. This is an official live stream of the CNCF and, as such, is subject to the CNCF Code of Conduct. Please do not add anything to the chat or ask questions that would in violation of the Code of Conduct. Basically, please be respectful of all of your fellow participants and presenters. With that, I'll hand over to Amanda. It's yours.
Thank you very much. Hi, everyone. I'm very happy to be here today. My name is Amanda Milberg. I'm a Principal Solutions Engineer from DoubleWord. And at DoubleWord, what we do is provide a secure inference platform for enterprises in regulated industries to host language models in their own internal environment. And I'm really excited to talk today about how to host an AI agent. And so we have a lot to cover today, and we'll save a section at the end for questions. So as things come up, I encourage you to write in the chat, and I'll be able to answer all the questions at the end. So without further ado, let's get started. I've decided to break down this talk into two parts. Because this title of how to self-host an AI agent really consists of two main things. So first, I want to talk about self-hosting. I want to break down exactly why self-hosting is relevant, especially if we talk about regulated industries, but really there's a notion of applying self-hosted to any type of industry, or there's reasons why you would want to do that across any industry. And then I want to talk exactly what it means to self-host. So when we're saying we want to self-host AI models, when we want to self-host LLMs, what does that mean? And what are the core components of what your stack should look like? I'm then going to talk about common traps and pitfalls organizations fall into where they're trying to self-host. And we'll obviously do a shameless plug of how organizations like DoubleWord can help. And then we're going to focus the second half of the talk on AI agents. So we hear a lot about AI agents, and I really want to break down the concepts of what is an agent, what is a MCP server. And then we're going to talk about how agents can have various levels of agency. And then we're going to bring these back together to talk about how self-hosting becomes more advantageous when you're talking about agentic use cases. And so we'll bring that all together with a walkthrough use case demonstration where I'll show you an example of developing an agentic workflow fully running in our four walls or our own environment. So with that, let's get started. So let's talk first about regulated industries and why they're struggling to adopt AI. And that's because when we're thinking about using AIs or using language models, there really are two ways to access them. And at first glance, both really aren't super appealing. So the first option is to use an API provider. So this is what you might be familiar with something like OpenAI or AWS Bedrock. And what we kind of hear from the field is that some of these API providers are still not approved internally by compliance teams. And if it is approved and you do get that approval, you're still dealing with data security and residency concerns when using third-party API providers. These models also rely on multi-tenant architectures. And for global organizations, model availability sometimes does not expand to a given region where they need it. And so while this is definitely an easy option to get started, you can maybe rely on your existing cloud API provider or use an API key. It might not fulfill all of the needs of some organizations, especially those in regulated industries. But the alternative sometimes isn't even more compelling because when companies try to self-host, they are expected to build this enterprise-grade inference stack that is as reliable or as scalable as an inference API like OpenAI provides. And this requires significant development time and ongoing maintenance, plus a team of highly skilled AI engineers and inference optimization experts. And so even though there's a lot of open source tooling out there, stitching together a full inference stack requires writing and maintaining a lot of glue engineering code. And so Both of these options, they don't sound too compelling, but let me explain a little bit more what I mean by this and the glue engineering code by talking about, the core components of a self-hosted stack. So if we're talking about the bare bones, what you need to make a self-hosted inference stack functional, essentially you need three things. So the first is hardware. You need access to some GPUs, whether that's your own on-premise cluster of GPUs that you may have, or something that you might provision through a cloud service provider. Because models need to run on GPUs, right? They're large language models. So they need these GPUs to power them. So once you have hardware, once you have GPUs available, the second thing is that you need is what's called an inference engine. And this is a unique aspect when we're talking about inferencing language models versus traditional AI or machine learning models like an XGBoost model or a linear regression model. And this is broadly because of three reasons. So first, like I just mentioned, large language models are in fact large. They need a higher amount of compute to perform inference, and that's their GPU. Their predicted output also differs, right? Because an LLM's output a token by token generation. So, the brown fox jumped over, or whatever the normal term is, versus when you're talking about traditional AI and machine learning models, they're single shot, 0 or 1, for the output. And then these outputs are also different. Or just like the outputs are different, the inputs are also different. So traditional AI and machine learning models are very structured, as opposed to LLMs, where you might be taking in unstructured image, text, or video data. And so while there are inference engines, and I've listed a few on this screen that exist that are open source that you might leverage in your stack, it does take mastery to configure these engines properly for your given use case. And there's a bunch of interesting inference optimization techniques that these inference engines provide, but you do have to configure it to kind of squeeze the most out in terms of whether you're prioritizing latency or throughput, which does become a little bit complicated. But once you have hardware and once you have an inference engine, the last thing that you kind of need in your bare bones functional inference stack is a model, right? This is something that you want to inference. And this could be anything from an embedding model to an image reasoning model to a text generation model. And most often we see folks pulling different models from open source repositories of things like Hugging Face, but these models could also be things that you fine tuned yourself that maybe you're interested in hosting and serving. And so this is kind of what you need to self-host an LLM. Or I guess I can rephrase it by saying this is what you need to have a functional inference stack. This is like your most basic sandwich, right? It's two pieces of bread and there's some protein in the middle. It's technically by definition a sandwich, but it's functional and maybe not super fulfilling. So maybe you go back to the whiteboard with your devs and you think of what is everything that I need around these core components to make it scalable and reliable? What do I need to try to make that sandwich more fulfilling? And as you kind of start to brainstorm of all the components that you need, you realize that that to-do list and maintenance gets a little crazy, right? So you start with your core components and then initial questions come up, like how do I create an API gateway to route requests to these models? What does authorization look like on top of my API gateway? If I'm having multiple requests to these models, how do I orchestrate them? How do I prioritize them? Would I need to add auto scaling? How do I limit the scaling of these GPUs? How do I scale down to 0 if I need to? How do I monitor the usage of these GPUs? How do I add usage and chargeback processes to justify these costs to the business? And these lists, or this spaghetti diagram, kind of goes on and on. And the takeaway here of my rant is that you can build this yourself and you can DIY it, as we say. You can do anything really with access to smart engineers, but just ask yourself, do you want your team maintaining infrastructure or do you want them building high value AI applications that you can show off to your board of directors? And that's my shameless plug here of the type of work that we do at DoubleWord. We provide a turnkey enterprise grade self-hosting inference platform that we can deploy directly in your environment. So we deploy that infrastructure that you need to have a resilient enterprise grade inference platform with OpenAI compatible endpoints so your team can focus on building the high value and high impact business applications. We give you that fulfilling sandwich, the 2 pieces of bread, the lettuce, tomato, onion, pickles, mayo, and mustard. And so now that we've spoken a little bit about what self-hosting is, what components it takes to make self-hosting successful, and how companies like DoubleWord can help, I want to shift the conversations to talk about AI agents. So, what are AI agents? Well, at the highest level definition, or one that I like to use, is it's AI systems that can independently reason, act, and adapt to achieve goals with limited supervision. And this is because agents do a few special things, and that's what you see outlined in the boxes below. They have the ability to reason, so they can understand a problem and create a plan. Then they can then act on that plan by using a suite of tools that enable them to execute against that plan. And then they can also adapt as they learn from their experiences. And so this is what makes agents different. This is what makes agents super unique and powerful. But does this also mean that we have no way to control agents? No, not necessarily, because each system can have various levels of agency. So this is kind of where I see folks getting initially maybe scared about agentic AI, because potentially they're thinking of agentic systems that have the highest level of agency that maybe we're not really prepared for right now. But the truth is that agents can have various levels of agency. And as we increase the agency level, so as we move down this chart, we essentially put more decision making in the hands of the LLM. So let's go through some of these examples one by one. So at the most basic level, essentially systems have no agency. This is usually where many of us start, or we have projects running in production today. In these systems, the program flow is entirely manual. An LLM has no impact on decision making. And this is an example of we ask an LLM a question, it processes the input, it returns a response, and there's no further action beyond that. But maybe folks are starting to move or experiment to that first level where LLMs are kind of acting as a decision router. And so instead of just responding to the LLM, or the question, the LLM decides which path to take. Maybe it says go path A or go path B based on the input it receives. And so this is an example of an LLM, for example, classifying a customer support ticket and routing it to the appropriate team, such as billing or technical support. And then the next level of agency is what we call LLM with tool execution. Now we're moving on to systems with higher agencies, which are becoming more common and what we're going to talk about today. So in this case, the LLM doesn't just make a decision, it determines which tool or action to execute based on the user's input. So for example, given a user's request, the LLM might decide to trigger an API, query a database, or generate a report. And like I mentioned, we'll demonstrate this later in the presentation. And so on, you can understand that there are higher levels of agency that can exist. You can imagine more advanced system where the LLM not only selects tool, but it also orchestrates multi-step workflows. It learns from outcomes and maybe it adapts dynamically. And this brings us closer to the systems that mimic tools and workflows that humans use in their daily lives. But today in the presentation, we're going to focus on this third level, the tool calling. And in doing so, I want to dive a little bit deeper into what exactly these tools can be. So when we talk about tools in the context of agentic AI, think of them as helper functions that extend the capabilities of an LLM beyond its base knowledge. So for example, an LLM doesn't inherently know the stock price of Google. However, it can use a tool to search the web, retrieve that information, and then return it to the user. And what's interesting is that these tools don't have to be LLM based in nature. So they can range from, and you see on the screen, things like performing database lookups, calling APIs, running machine learned predictions, executing custom code, or calling another LLM. And so you can imagine how many tools could be useful for a single organization or across an enterprise. And you could imagine how helpful it could be if these tools could be standardized or reused. And that's really the concept of MCP, or Model Context Protocol. It ensures tools are interoperable and can be seamlessly integrated into workflows, making these AI or agentic systems even more powerful, because regardless of the downstream AI model, these tools can be reused and placed across each model. And so, one example that I heard once that I like, or helps me explain or understand this concept of MCP, is MCP for AI applications is similar to like a USB-C port. Um, just like you can connect any hardware USB-C port, you can connect any tool to an AI model through MCP. And this is impactful in two ways. It gives us a plug and play type of approach for these tools, which means we can take our own tools and bring them to any AI model, whether it be OpenAI, Anthropic, or a self-hosted Llama or Quen model. And we don't have to bring custom integrations for each model tool combination. It also gives us access to this tool system or repository. So there's a lot of readily available tools that are released by providers that you can essentially just download, serve, and use. And this is very similar if you can think of how you interact with something like a REST API. So now we understand agents, we understand tools, we understand MCP, and I want to bring it back to the concept of self-hosting, because the case of self-hosting becomes even more compelling when you're talking about working with agents. And I'll give you a few examples to justify this. First, agents use a lot of tokens, much more than a single shot LLM. In fact, it's estimated that reasoning models can produce up to 20 times more tokens. And so when we think about API pay per token costs, it's something to consider versus the fixed cost that comes with self-hosting models. There are also technical advantages to owning the whole stack and therefore able to optimize each part of it. For example, one thing that we do with a lot of customers is in our self-hosting stack, we use a technique called prefix caching. And what that does is it optimizes LLM inference by storing and reusing common input prefixes. And for agentic use cases, they're constantly reading the context of what the tools can do, the definition, which I'll show you kind of how we defined ours in the demo. But if you think about the cost and performance improvements you can get if you are caching these definitions, they could really become quadratic in terms of the performance or input. And the other aspect is when you're using self-hosting, you're able to host fine-tune variants or LLMs that are good for specific agent tasks, which can also be more performant. You can also use smaller LLMs coupled with a few agents to achieve the same result as maybe a larger LLM with more parameters. And then, finally, the thing that I always constantly hear is control and compliance, right? With self-hosting, you keep the sensitive business data entirely within your own four walls. And that way, whether you're sending customer information, sensitive data information, you can feel 100% secure in that everything that you're using your LLM for is staying privately in your own environment. And so I'm always someone that likes, I kind of need to see it to believe it. You might be like, wow, Amanda, you're talking about all these cool and interesting things, but how does it work? How does it do it? Seems complicated. So I want to kind of show you all of this in practice, walking through a quick demo in a very interesting use case that folks might be familiar in. It's called like Know Your Customer or KYC onboarding. So in case you're not familiar, I'll give you a little background of what KYC is, or Know Your Customer. Essentially, what it is it's a mandatory process at a lot of financial institutions, and you essentially need to identify and verify an individual or prospective client's identity when opening an account in a bank. And so usually when I onboard a new client, maybe I want to check that I don't know, there's no negative news surrounding them, or they are not in a specific data, they're not politically exposed or in a database or something like that. And there has been a lot of advancements in automation of KYC to date, even before the kind of huge, release of ChatGPT in like 2022, there's been a lot of interesting scraping of web searches and negative news searches around KYC, but I still think that this could be an interesting example to walk through, because this process involves a lot of separate steps, such as doing document verification or checking a name against a database, like I mentioned, and then calculating an overall risk score. Maybe that's using a machine learning model that you already have deployed. And so I want to talk through what would it look like if we give an agent access to all these tools. Well, this is kind of the high level illustrative pipeline that we're going to show that we developed, which involves two specific models. So we start with a reasoning model. It's a Quen model. The Quen model will sit kind of on top of all our specific tools, and it will be able to take our user input and then autonomously decide which tool is the best depending on what I ask. So that's our Quen model. It's a 1.7 billion parameter model. So it's actually a pretty small model in comparison to the largest large language models. And we've deployed that and actually have it running in on-premise cluster here. And then all of the circles that you see are little tools that I created as part of my MCP server, which I'll show you kind of the code definition of that. So one, like I mentioned before, these tools can be all different, but we have a database lookup that looks in the politically exposed person's database. We do like a risk score calculation where we take a bunch of these inputs and then we give a high, medium, or low risk score. We might also do things like an ID verification check. For that, we can call another LLM, for example, like a Llama multimodal model that can take in an image of a license or a passport and check that it is a valid license. We can also see this expanding to doing things like adverse news search and searching the webs, et cetera, et cetera, et cetera. But what I'm going to show here is kind of my Quen reasoning model being my highest level model, and then exposing it and giving access to all these tools that I've defined in my MCP server. So I did a little prep work here. Before, the first thing I did, like I said, is I deployed models. So I got models up and running. For that, I used DoubleWord, deployed it, got this really nice OpenAI compatible API that I can essentially use to create or call LLMs wherever. And then I created an MCP server. So if you've never created an MCP server, my screenshot of the code is my advice to just try it. It's actually really nice in terms of you can use, a bunch of different packages to create it. And essentially what you do is define the definition of your tool, which is what you see in my kind of like docstring version here, in terms of what it can do, your input and your output. And then you just write the code as if whatever the tool is trying to do. So this one is an example of connecting to a database where I essentially call an API, I get a response, and that's my tool for looking up someone to see if they're politically exposed in the database. And so what my reasoning model, my top level model will get is essentially this definition, and it reads all of those definitions of the different tools. And then it kind of picks which one it wants to use based on my question. So that was the prep work I did. I deployed the models. I created my MCP server. Once you create the MCP server, you serve it somewhere, and then you have the ability to connect your MCP server, like I said, to any tool, whether that would be like your Claude or your OpenAI like browser-based interface, or in my example, one of my self-hosted models. So now I'm going to walk you through, I recorded a little demo of the full application, and we're going to kind of pause and talk through individual aspects of what we did here. Cool. So to start, I used an interface called Open Web UI. It's a great open source package if folks are familiar with it, to be able to essentially connect like any model or multiple models to. You can also connect your MCP server, and you get this little chatbot type interface. And so really nice when trying to make like quick demonstrations of showing off the capabilities is I don't have to make this chat interface. I can just use Open Web UI. So what I did here is I connected my Quen model, like I said, that I deployed in double word to OpenWebUI. So that's just using the OpenAI compatible endpoint. You essentially said, this is where my model lives. And then I connect my MCP server to OpenWebUI as well. So whether this is OpenWebUI, whether this is Claude, OpenAI, something that you have running, maybe a chatbot in your own internal environment, it's all the same idea of you just connect everything together because they're all served on different ports. So you could see here that my tool is now aware of my MCP server. And I have a few different tools that I outlined here, similar to when I went over before. So I have the tool to look up the person's name in the PEP database, the tool to calculate a risk score, and a tool to check an uploaded ID and return back if it's valid or not. And so again, my model will kind of choose what it wants to do depending on what I input it. If I give it a document, maybe it would use the document check function. If I just say, look this up in the PEP database, maybe it will just use that PEP post function. And so to play around and to have some fun here, once I kind of have my 3 tools defined, I can start asking questions. So I start with just seeing about me. So I say, can you perform a check on Amanda Milberg? And so I could see here my model is thinking. I could see that it's thinking right now, it's using the tool. So it's decided to look me up in the PEP database. And I can see that it responds based on the context of the tool that I'm not a politically exposed person. That makes sense. I've never had a career in politics, but we could see what it did is it used the tool function, it checked it, it cites it, it passed in my name as a parameter, it got 0 hits, it decides I'm not a PEP. Okay, great. I'm clearly not high risk for this bank to onboard. But maybe I try again with someone that I know is a politically exposed person, the president of the United States. So I asked, please perform a check on Donald Trump. I could see now the model is thinking. So this is my Quen model adding those reasoning tokens. So you could see that the model is thinking. This is that 20x type of tokens that I was describing that's different from the single shot LLMs. So it says, okay, I can see that my job is to see what is Donald Trump's risk score. I can look at specific IDs. I could see that they want their risk score checked, blah, blah, blah. I should mention this. The answer is straightforward. The risk score for Donald Trump is high as listed in the context. And again, it gives me these 3 tools to understand where it came from. And so that's just to show you kind of to get your brain moving of how simple it may be to start developing these agentic use cases. I encourage you to use OpenWebUI or your current favorite tool of choice. Try typing up a little MCP server, try connecting to and asking some questions, and see how the knowledge of your LLM or the usability can just expand by adding these specific tools. All right, great. So we've done a lot in the last 30 minutes, but I wanted to kind of summarize these key takeaways before we go into answering, hopefully, some questions that you all have. So to summarize, why is self-hosting AI important? Self-hosting AI, it enables scalable and cost-effective deployment that puts companies in full control of their AI infrastructure. We obviously believe here that this is crucial for true AI ownership and differentiated AI. We see a world where companies will have a full self-hosted stack, a mix of self-hosted and closed source models. But we truly think that in order to have that differentiated AI, self-hosting some part of your full LLM suite is important in doing so. The second is talking about agentic systems. So we spoke about what agents are, what MCPs are, and we really what agentic systems are doing is showing the evolution of LLMs as simple processors to AI that can the AI that can reason. And that really creates new opportunities for automation, right? We can have LLMs and agentic systems follow steps that we do in our everyday, even if it's like, I sit down, I check my email in the morning, I plan my to-do list, and then I start actioning against it, right? These are all ways that we think and tools that we use that we can put more into agentic systems to hopefully enable LLMs to help us more in our current business lives. And then we kind of spoke about how self-hosting AI plus the use of agentic system will lead to a kind of strategic advantage to your organization. So by coupling these both, or we're talking about agentic system, self-hosting should be right next to it in terms of stuff that you're interested in. And this is because it's token intensive, it's a multi-step nature, and so they're really well suited for self-hosting inference optimizations like tool caching, someone also mentioned in the chat. And it really will deliver both cost savings and enable secure processing. Um, so with that, I'm open to answering any questions that you may have. I think it's best to write them in the chat, and I can kind of answer them one by one. I also put my email there as well as my LinkedIn. It's just my full name, Amanda Melberg. So if you have additional questions or want to talk more about agents or self-hosting, feel free to reach out to me after this. I always love to chat and talk with folks.
So right now, I don't think any questions are there, Amanda. So maybe do you want to say something lastly, or shall we wrap up?
Happy to answer any questions now. If not, like I said, feel free to contact me offline after. But yeah, I guess just thanks for having me. It's always so fun to share knowledge, and I hope that if anything, this just helped and inspired some ideas of um, starting kind of building. Um,
Yeah.
is there any platform that you recommend I shall I don't know if I understand the question. I don't know what AutoGen or ADK is. Do you mind? um,
Arvind, do you mind, elaborating your question so Amanda can take it?
oh, Agent Development Kit, maybe. I just did a quick Google search. um, I used in my example, I used this thing called Fast MCP, which was again like this isn't a production ready system. This is more of just like a demo, but I thought it was really easy to set up. It was a like a GitHub package or open source package, I can't remember. I defined the tools and then I was just able to serve it on in my case, I just did it locally. So that was kind of how I built the MCP server. And then all of the self hosting in terms of spinning up the models and getting them connected because they're kind of two separate things, like the model and then the agent itself. The self hosting was done in Double Word because that's just like what we do. So if you're interested, reach out. We could talk about that further. I also mentioned there's a ton of open source tooling if you have that skill set, but also always happy to talk about self-hosting in general. So the agent is one thing, like the MCP server, and then it called models that were being hosted by DoubleWord.
Okay, so I guess that was all, Amanda. And yeah, maybe you all can reach out to Amanda if you have further questions. And it was very nice session. We enjoyed the interaction, and thanks everyone for joining our latest episode of Cloud Native Live. Thank you, Amanda.
Thank you.
Okay, see you. Bye bye.